All right, so I'm going to do these problems. I'm kind of guessing on directions since I don't have my book. But I think for these two, we're supposed to show that they are inverses of each other. So we could go a couple ways. We could just like find the inverse of this one, you know, write it as this, switch the input and the output, solve for y, add 6 to both sides. And see how that equals that? That means they're inverses of each other. So that's one way we can show it. The other way we can show it is we can go f of g of x and get x out of it. And then also go g of f of x and get x out of that. So like if I plug g of x into f, notice f is like input minus 6. That's what f is. G is x plus 6. So if I plug this into there, I have x plus 6 minus 6, I just get x. So that part works. And if I go the other way, if I plug f into g, notice g is just input plus 6. My input is f of x, which is x minus 6. Minus 6 plus 6 is x. That shows that they're inverses as well. And then on this problem, I think you're just supposed to find the inverse. So the way that you find the inverse is you replace the function part with a y, just because it's an easier symbol to deal with. And then here's where you're actually doing the inverses. You switch the x and the y. So like the x takes the y spot, and the y takes the x's spot. And you just solve it for y. Get y all alone. So subtract 5 from both sides. Divide by 3. And notice I have y equals x minus 5 over 3. That's the inverse of f of x. So I can say f inverse of x is x minus 5 over 3. Notice they undo each other. If I plug a 7 into here, I'll get an answer. If I plug that answer into here, I'll get my original thing that I plugged in my original 7 back.